Hello, everyone, and thank you very much for joining us today in this event. My name is Judith Sainz Pardo. I'm researcher in the Spanish National Research Council, and I'm involved in the EOSC SIESTA project, both from the technical side, but also being the responsible for the impact of the project. Today in this webinar, the idea is that we are going to introduce the EOSC SIESTA project, the EOS ENTRUST project, and the EOS TITAN project. And in order to do so, we have divided this webinar into main parts. In the first one, we are going to give a brief introduction to the three projects, and then we are going to move to the technical side. And then, so that you can be able to interact with the speaker to ask your questions, we have activated this question and answer system. So you can join the system via slido.com and enter in this code that you have in the slide, or you can simply scan the QR code. You also have the link for the question and answer system in the description of the YouTube video. So I think that then we can start with our first speaker of the day. And in particular, we are going to start with the EOSC SIESTA project. And in order to introduce the project today, we have here Álvaro López García, who is the project coordinator of EOSC SIESTA and is a tenured scientist at the Spanish National Research Council. He is the coordinator of the project, but he's also coordinating other and has coordinated other EOS-related projects. He holds a PhD in Science, Technology and Computing from the University of Cantabria, and in the last year he has been working on the adoption of cloud technologies by scientific data centers and users, delivering innovative services for science research under specifically the scope of the European Open Science Cloud ecosystem. So then, Álvaro, I give you the floor. You can start sharing your screen. Thank you very much. We can see your screen, but we cannot hear you.
Okay, sorry, I was muted. I was saying thank you, Judith, for the introduction. And I was asking if you could see my screen. So let's go ahead. So thank you all for joining today. I will give you now a brief introduction of the EOSC SIESTA because I don't want to consume too much time in order to give time for the technical discussions afterwards. So in a nutshell, our project started in January 2024. We are one of the three projects that have been funded in the EOS 0106 call from 2023 that was aiming to enable a scientific analysis of sensitive data sets in the context of the European Open Science Cloud. Our project is implemented by 12 partners with different profiles from academia and research, law firms that deal with all the legal aspects of dealing with sensitive data, proper individual rights and IPR, industry and SMEs, and also we involve the Statistical Office of Spain, the National Statistics Office. Our objectives, the main goal of the project is to deliver this a set of cloud-based environments that can enable researchers to analyze sensitive data, environments that are built in a reproducible way, also a set of services to ease the secure sharing of those data sets through state-of-the-art anonymization techniques. This overall goal is structured in these 5 objectives. So first of all, to enhance the EOSC ecosystem with this set of cloud-based trusted environments, to deliver a study of the feasibility of the FAIR principles over sensitive data, because we have identified that there is a friction between both of them. Therefore, we are delivering a comprehensive analysis of the applicability of the FAIR management principles for sensitive data. Then delivering a set of tools for the secure anonymization and pseudonymization of datasets in order to be able to securely share or process sensitive datasets. Also provide right holders and data owners with best practices and methodologies for the release of sensitive data. And last but not least, extending the service offer through the portal, not only with this cloud-based trusted environment, but also with additional tools like data anonymization tools and data sharing tools. Our concept is that we think that there are needed different access methods depending on the data sensitivity, from the usual collaborative development environments like Jupyter Lab or Jupyter Hub for low-risk data, to more constrained means of access by using, for example, VPN or remote desktop with limited functionalities. We also leverage internal repositories that allow just to install some software components that have been audited inside of the trusted environment. Ensuring that the data that is ingested is anonymized and that the data that is getting outside of the environment can be evaluated in order to do a risk analysis of the disclosure of the data. All of this log with tamper-proof components that log and provide us a trace of all the relevant transactions in the system, with tight integrations with the EOSC, well, at the time of writing the proposal, the EOS Core and EOS Exchange, so with the authentication and authorization and so on and so forth. The concept in the end is that we need to provide safe and trusted access to sensitive data. And in this sense, we have defined a tiered model for data sensitiveness that range from 0 to 5. So we have fully open data that we don't need to use a trusted research environment, low risk data, that is data that has been pseudonymized with a very low linking risk, low risk, strongly pseudonymized data sets with some indirect identifiers, average risk, high risk, and so on, until we arrive to very high risk, where we have very sensitive personal data with highly confidential, for example, governmental or commercial data coming from industry. Our focus is on categories 2 to 5, delivering services with increased level of security, different entry methods, and different restrictions. And the underpinning concept of all of this is that we will deliver the environments via infrastructure as code so that they are reproducible, and that we need to model this data sensitiveness model in a semantic way in order to deliver policy-based access to the system and machine actionability. This tiered model for data sensitiveness has some implications. We think that data sensitivity is not static. It depends on the context. It depends on the people that is accessing the data. And therefore, we need to dynamically define it via a set of policy tooling methods, so that we can, depending on the data rights holder, depending on the audience, depending on the resource provider, we can define different sensitivity levels. Different sensitivity levels are coupled with different access models, as I'm putting here some example. For example, we can allow remote interactive sessions for level 0 to 2, remote desktop for levels 3, remote desktop with limited capabilities for level 4, or symmetric multi-party computing for secure multi-party computing, for level 5. There are some other components that also have some security implications, like this audit system has to be its data has to be considered also high sensitivity, and therefore we aim to address this via infrastructure as code and semantic modeling, so that we are able to map platform deployments, user executions, and data storage in providers that meet with some security criteria, like, for example, our own institution that is certified with the ISO 27000 or the National Cybersecurity Scheme. One challenge is to define this data sensitivity semantic modeling in order to ensure the consistent and dynamic enforcement of the usage policies according to the data sensitiveness and the provider characteristics. We need to work on establishing, we are working, on establishing this a basis for the trusted research environment, sensitive data governance system via semantic modeling and policy enforcement. This is a work that we are starting now and that we are planning for the last year of the project, where we will work in 4 different aspects. On the one hand, we are modeling and defining and modeling the data sensitivity via DPV, the vocabulary for the W3 consortium, in order to define a formal machine-readable risk classification of our data. Then we define the user rights using the ODRL agreements, so that we can negotiate the permissions and prohibitions that are granted to the researcher. And then we map this formal definition from ODRL to OPA or REGO in order to apply the policies in the underlying Kubernetes platform or platform infrastructure. And all of this generating audit trials in the tamper-proof logging system for all the policy decisions that the platform delivers. This is our high-level architecture. I don't want to enter into too many details, but basically, because then Andres will cover some of them, our systems are depicted in pink, in purple. So we have a set of common tools that deliver a common functionality to the compute and storage system, and an audit system that is registering the transactions that are being applied or that are being carried out in the rest of the components. The compute platform is the one that allows us to give access to the users to an interactive environment, to analysis environments in order to deal with sensitive data. This is based on trusted execution environments and Kubernetes clusters that Andres will explain later on. In order to ingest the data, we have a secure storage where we deploy storage solutions for the users and together coupled with assisted anonymization tools in order to ingest the data. And then we have the egress service where the data right holders can assess the risk of a given analysis, taking into account the data sensitiveness, and they approve the stage out of the data, or they can deny it. And then we have the common services that include all the auxiliary services that are needed in order to deliver the secure compute and secure storage systems, like authentication, the mirror, secret management, IDS, and so on and so forth. A couple of early results that we want to make you aware of. This report on the tension between fair guiding principles and sensitive data. As I already mentioned, we have delivered this a comprehensive report where we are mapping the interaction between the 15 FAIR principles and sensitive data management. We analyze the applicability of the principles to the different grades of sensitiveness that we have defined and their metadata. And we also work in the interplay between the principles and the variables that may hinder the application of the principles with sensitive data. This is published in open access via Zenodo. This is one of our deliverables. And you can access it via the QR code or via the DOI that is in the screen. Another early result that we think is really interesting in the context of this workshop are the data anonymization tools that we have released. These are 2 complementary tools and a service that can be run locally to anonymize data. On the one hand, we have HANA. On the other hand, we have PyCanon. And HANA is a Python library that allows us to anonymize tabular data using the 9 most widely used anonymity techniques, from k-anonymity to delta disclosure privacy. And PyCanon is a tool, a separate tool that allows us to check the level of privacy according to these anonymity techniques. We are also delivering a web-based interface for HANA so that you can anonymize and explore the data from the browser. This is a service that is provided in the platform itself that can be used for demonstration purposes, but for production you can download it and you can execute it via Docker container in your desktop, and you can, therefore, your sensitive data will never leave your computer. So where we are now, we are entering into the last year of the project, where we are working on the final steps in order to be able to provide the uptake of the system. Our architecture is finalized and stable. We have implemented the confidential platform and confidential computing via Kubernetes, as we'll explain later on. We have delivered the anonymization tools, and they are released and already being used by some projects. And then we are entering into the security hardening of the software components on defining this data sensitivity, semantic modeling, and policy enforcement, and the final end-to-end integration of the use cases. All of this will allow us to deliver the second platform release by the end of the year, together with the SIESTA risk control tools for data stage out and the best practices for DevSecOps in the context of the EOSC, but also for the broader context of distributed infrastructures. Thank you all for your attention. This is all I wanted to share today. I don't know if you have any questions, or if we can go to the next speaker and maybe have all the questions collected at the end. Thank you.
Thank you very much, Alvaro. I think that we can start with the questions that you have, because for some of them, I think that you need your slides. So let me start with the first one. The first question is, am I correct that the level 0 is anonymous and then all the other levels, 1 to 5, are not anonymous and then they are covered by the GDPR?
Yes, level 0 is open data, so data that has been completely anonymized, or data that does not involve any personal or sensitive data. For level 1, this is pseudonymized data with very low linking risk, and therefore it does not enter into the GDPR because they can be considered also anonymous data. But from 2 to 5, yes, this is data sets that well, they are covered by GDPR because they can be de-anonymized or they can be linked, and therefore they need to be taken with caution.
Then the next question is, in the slide 5 and 6, how does SIESTA implement different sensitivity levels for different audiences? Are users assigned to data tiers? Who determines this?
This is something we are working now in the second half of the project, because there is the problem with this data sensitivity that is not static. So what we are doing now, we have starting from DPV, the data protection vocabularies, in order to model the data sensitiveness. Then we use the ODRL, which is the open ORDL, ODRL, which is the open the digital rights language, where we can couple access profiles to the data sensitivity. So we can generate a set of what we think are the intended actions for a given data sensitivity level. And this is static. So for example, for level 5, you can only use SMPC methods to access the data. For level 4, you can access via a remote desktop, but you cannot copy paste, you cannot download data, you cannot copy data outside, and so on and so forth. And these are static levels. And these are defined by the data right holder. So these are the default values that apply to a given data sensitivity tier. However, we think that this is not written in stone, and depending on who is accessing that data, you can relax the restrictions on the data sensitivity level. And this is the part that is dynamic, that we have not yet implemented, because it is planned for the second half of the project. And this is a process that involves 3 different actors. So one is the data right holder, another one is the scientist or the analyst that is accessing the data, And the third one is the resource provider, where the data will be stored or where the data will be processed. And this is a dynamic process that needs to be negotiated and that can end up in a different ORDL agreement that can be applied, that can be translated to the OPA REGO policy, and that they can be enforced at the resource provider level.
Okay, and we have more questions, but some of them I think that will be covered in the next presentations. Otherwise, we can came back to these questions. But just to take one more, in the slide number 12, have HANA and/or PyCanon been applied to the data of each of the 5 Siesta use cases? And I think that maybe I can answer this one. We have used, well, some of the use cases have already tested HANA, specifically in the epidemiology domain. And for other use cases that we have in the project, such as the medical imaging one, we have tried other techniques, as Alvaro has already mentioned, such as differential privacy and so on. And also they have developed their own tools that are specific for such use cases. In addition, for the energy domain, they are already making some tests with HANA for anonymizing some of the tabular data that they have. Another question that I can also take is that the slides will be shared. Yes, for those who register in the Indico webpage, we are going to share the link to the video. The video will be kept in YouTube, and we are going to share the slides as a red folder.
Just let me add on top of what you mentioned. These two tools are focused on tabular data only, because these techniques can only be applied to tabular data. For other cases, like for example, we have one on medical imaging. We have developed specific tools for dealing with the specific data sets that the use cases are dealing with, like bit scramble, for example, that provides an anonymized version of the original data set. I did not introduce them because they are too focused on specific use cases, but we have other anonymization tools, more use case specific, that nevertheless can be applied to similar use cases on medical imaging, for example. Yeah.
Okay, so thank you very much, Alvaro. I think that the other questions, otherwise we will not have time. Some of them can be covered probably by Andres in his technical talk. So thank you very much. And now let's move to our second speaker. And in this case, we are going to move to the EOS ENTRUST introduction presentation. And for that, we have Ulrika Vihervali, Master in Science and PhD. She is based in the CSIC IT Center for Science in Helsinki, Finland. And she leads an open science project in international collaboration and partnerships. She co-leads the Trusted Research Environment Providers Work Package in EOS ENTRUST. And she also works across EOS projects, including the EOS Finland candidate node. So thank you very much for joining us, Ulrika, and floor is yours.
Okay, thank you very much. And I'll just confirm that you can see the slides and hear me. And okay, perfect. Okay, so thank you so much, everyone, for coming along today. And so my name is Ulrika Vihervali, and I'm presenting on the ENTRUST project, and I'm based at CSC IT Center for Science in Finland. Now, what I'll do today is just give you an overview of ENTRUST and how the project is set up, highlight the work that we've done so far, and then also explain the work that we will do in the last remaining 14, 15 months, however many we have left now. But we started in March 2024 and we run until February 2027. And the mission of EOSC ENTRUST is to create a European network of trusted research environments for sensitive data and to drive European interoperability by joint development of a common blueprint for federated data access and analysis. Now, let's see, next slide. Yeah. So the ENTRUST consortium is quite large, as you can see on the slide, so don't worry about catching all of these. But there are 34 partners across 15 different countries. And if you look to the bottom left here, I've highlighted Alexia. So Alexia is the coordinator of the project, but the project coordinator, Peter McCallum, was double booked today. So I'm taking this us through the overview overall. But we've got a really nice spread across the European landscape for TREs. And these are the objectives of the project. So we are aiming to create a tightly knit network of nationally operated and governed TREs capable of supporting large-scale European research. So the objectives, there are main 4 objectives. So the first one is then to create a European network of TREs that are linked to EOSC and Euro-HPC to enable transnational collaborative research on sensitive or restricted data. The second objective that we have is for TRE providers to implement, validate, and promote the capabilities through a European framework using common standards and shared legal, operational, and technical language. The remaining objectives are for national funders and governments to understand the network of TRE capabilities as serving their needs and how TREs support their national priorities and their contributions to selected transnational programs. And the last objective that we have is that ENTRUST is embedded in EOSC and the European data spaces and fosters an ecosystem of public, private, and joint venture providers of TRE services. This is how the project is set up. So I will talk you through this slide briefly. So obviously here on the left, we have the big powers. We've got we have the Commission, EOSC, European Context and Data Spaces, ESFRI. We are, of course, informed at the top here by European researchers, as well as, the awareness of the social impact that we are hoping that the project has. At the bottom here, we have the national funders and policies, which, of course, are very much informing the kind of these bigger frameworks around TREs. And here we have the driver forum here, and we have 4 drivers, and I'll go into what they are in just a minute. But these 4 drivers then inform the requirements for TREs. We have the provider forum here. The provider forum is what it sounds like. So this is a collection of TRE service providers. And between them, the drivers and the providers, we have the coordination team for the project, but then we have these technical work packages. So we have the architecture work package, and we have the safe and fair technologies work package, and a safe workflow processing work package as well. And today we'll hear from one of these, and again, we'll go into this a little bit more. But to highlight that today we'll hear in the technical talk on the AAAI blueprint in particular, but there's a lot more technical work also happening around this as well. And of course, we've got the communication hour outreach, which is also what we're doing here today. Okay, so let me just kind of talk you through the different work packages and again say what's the work that's been done so far and what are the next steps. So we'll go through them in the number of the work packages, and that means we'll start with the driver forum. So these are the 4 drivers that we have in ENTRUST. So driver 1 is for federated human genomics as a catalyst for European TRE provision. Driver 2, common standards to enable transnational sharing of administrative or register and social science data. Driver 3, enabling secure transnational reuse of clinical research data in a legally and ethically compliant manner. And driver 4, public-private interactions between TRE in health and environmental data. So the drivers have a really nice range of representing different kinds of sensitive data and then representing different kinds of requirements needed for the TREs that handle them. So from the driver perspective, what the drivers then aim to do and what's the key role in the project is that they inform and validate the blueprint and technology development, and they provide the blueprint work with requirements, as well as then identify gaps that we have. And a few highlighted outputs so far is the validation report of the year 1 blueprint, And then also a more recent one, revised driver requirements from August of this year. And when you get these slides, you can click through to all of these links, but all of these are also in the ENTRUST Zenodo. That's also what we use to publish these. Upcoming, I put it in bold here that there is a validation report of the new Year 2 ENTRUST architectural blueprint that's currently being developed, and that the deadline for that is February. So that's coming up quite soon. And still to come in the final year of the project will be, again, revised requirements for TREs from the drivers, and then also a final report on the extent and impact. Then for the providers work package, so that the TRE Providers Forum is, the home of this forum is in this providers work package, and the forum consolidates existing expertise and good practices for the common interoperability blueprint. So again, this is what the Provider Forum has been doing and what we will be doing with the time that we have left. So from the Providers Forum, we get a TRE inventory. There's been 2 versions so far. The one we published in August captures the capabilities of 25 TREs across 11 countries. From earlier this year, we also had an adoption and evaluation report for the first version of the blueprint. And from the Providers Forum, we also run an open TRE provider forum. So this is a provider forum open to all. You don't have to be ENTRUST affiliated. So if you are a TRE service provider, we have these monthly meetings where we get TRE-related news, landscape updates. We also present on our TRE work. So if you are not yet a member of this forum, then you can join. And when you get the slides, there's a link there. You just add yourself to that mailing list, and then you get the calendar invites. The next meeting is in January 2026, so that's something you can pick up next year. Also, early next year, we'll get to the adoption and evaluation of the Year 2 blueprint, as well as EOSC readiness analysis. So this is a conversation that we are having right now and working our way through, is to really think of, well, how can TREs operate in the current EOSC landscape and become part of EOSC offerings? This is something that we're currently figuring out. I'll move on in the interest of time. So we have the architecture and technologies work packages. So there are 3 work packages here focusing on the technical development. So the blueprint architecture for composable TREs and foundational technologies. We have the TRE blueprint. So here we are gathering the requirements and building a roadmap for a blueprint that enables an interoperable network of TRE services in Europe. Then trusted researcher identities and data authorization. And this is dealing with the need of higher trust in the authentication and authorization in the TRE context. And this is what we'll have the technical talk on today, later on. Then RO crate and workflow processing. So the combination of RO crates and workflows, providing the interoperability framework and execution approach for practical pan-TRE analysis. And again, highlighting some of the outputs and what we've done so far, where we are going. So from here, we have a TRE provider catalog. The Year 2 version was published a few months ago. And we've got the blueprints and of course roadmaps as well for how we get to these blueprints. We also have a blueprint for the AAAI for TREs that came out in February of this year. And then we have the validation of existing efforts listed, some there, but here a deliverable for deployable demonstrator of digital objects and workflows developments. And these outputs are also supported by training packages for blueprints and for workflows as well. The Year 2 version of the ENTRUST blueprint and interoperability framework is just about to be published. I can't give you the exact date, but it's in these coming weeks. So we're just about to add this to the Zenodo with updates from Year 1. There will also be then a final version of this in the final year. And also in the final year, we'll have a final version of the TRE service provider catalog, as well as the deployable demonstrator, and also a final version of the AAAI blueprint. So by all means, go take a look at what we already have, but also keep in mind that we are still developing these in the final year, and there will be one more round of updates to come. So these are the outcomes of ENTRUST overall. So, we have a very, grand ambition. So taking European research beyond the state of the art. Well, what do we mean? So we are aiming in terms of European collaboration. So a European network of TREs expanding the access of EOSC to resources and valuable data sets for research. In terms of European connectivity, delivering a blueprint for connecting TREs into large-scale networks for federated data via a standard set of methods. In terms of fair data workflows, conducting secure and reproducible cross-TRE analysis of sensitive data. And then in the context of European HPC, we are piloting inclusion of Euro HPC sites into the TRE network as well. So we've been quite busy, and we will continue to be busy in the months that we have left too. So that was a very high-level overview. So thank you all for your attention.
Thank you very much for your presentation. And we already have 2 questions that we can briefly take. So the first one is if you could give some details about the use cases of the trusted research environments. I assume that it's talking about the use cases that you mentioned on genomics and
the drivers. Is that?
I suppose.
Okay, so this might be, I assume you're maybe then, this is what it's asking, is for the drivers. Yeah, the details of these, again, I don't remember from the top of my head who exactly is behind who of the drivers, but you can find the details on the website for EOSC and Trust, and you can actually see which organization is running which, and it will also give you a little bit more detail rather than this high-level description of exactly what kind of data is in question and what's the context for each of these drivers as well. But it's a really nice spread of different types of data, which I think is very, very helpful for ENTRUST.
Okay, thank you. And the other question is, as in the Siesta case, you talk about trusted research environments and you also talk about genomic data. How is the European health data space is taken into account?
Yeah. So, I kind of highlighted here that, where was it? Maybe here. So we are in particular thinking of how do we link with EOSC, obviously being an EOSC project as well. But the European health data space is also another kind of big force, in the landscape that we need to figure out our relationship with. So currently we are just making sure that we know what's the latest happenings there and having a think of, well, how do we align there? But we don't currently have, we're in the same sphere, so to speak. But we are just trying to make sure also that we stay kind of up to date on where we are. But it's still a big question of, in the future, how can ENTRUST also be part of that space? We don't really have the answers for that yet. We don't have the answer for EOSC either. So these are both things that we are kind of figuring out, because the landscape is evolving so fast. Even during the time that ENTRUST has been running, both of these things have been developing at their own pace. So it's kind of a running target in that sense.
Okay, and one last question. Will you be piloting further in the project? When can we expect to hear on that? And if other research institutions, not from the consortium, can apply?
So if I guess this is here for the upcoming technologies. So these will become public in different times. So for the early versions, we just kept them within the project, but now they're kind of reaching a level of maturity where we have public versions of them. The year to provider catalog is an example of that. So I encourage everyone to go and take a look. In terms of, we are kind of testing these and testing adoption with the project partners currently. But if you are interested in testing some of these at your end, then obviously we very much also welcome that feedback. So just make yourself known to us if you are interested. But we don't have the capacity to run full scale pilots outside the project itself, so to speak. But obviously we welcome feedback, certainly, if you are interested in taking a look at the outputs.
Okay, thank you very much, Ulrika. We have to continue. And now we are going to move to the EOS TITAN project. And in this case, we have here with us today the project coordinator, Antonio Scarmeta. Antonio received his master's degree in computer science from the University of Granada and his bachelor degree in science also in the University of Granada with honors, and the PhD degrees in computer science from the University of Murcia in Spain. He's a full professor at the same department and university, and he has worked on different research projects in the national and international area concerning networking, security, IoT, and 5G area. He has published over 200 international papers, and he's a member of several program committees. So thank you very much, Antonio, for joining us today, and the floor is yours.
Okay,
we can see your screen.
Yeah. Thanks. Okay, so thanks for the first of all, thanks for the invitation, and also thanks for I think that a quite good workshop that we hope we can have today. Okay, so basically, I'm going to, in my case, I'm going to be either in the general presentation and later also on the technical side. So anyway, I will not try to take too much time in the first presentation. Just to mention that in our case, TITAN. As the name indicates, it's about generating a trusted environment for confidential computer and secure data sharing in the context of the EOS. And here you can see the different partners that we are already involved. And you will see later where we are trying to cope with two different use cases that we already are considering. Similar to the other project, basically the objective here is obviously to try to bring basically the idea of the confidential data collaboration and data confidentiality in the context of the EOS. And specifically in our case, we focus mostly on the privacy preserving data processing aspect and how different technologies can be applied for supporting this data sharing, taking into account certain level of privacy and treatment between the different nodes. Apart from that, obviously, one of the work that also we are doing, and it's one of the targets of the project, is how this can be integrated also with the idea of using certain machine learning or AI application on the different trust execution environment that can be linked to the issue also of the derivation of data that can be treated in this case using this technology, and how they can be obviously be supporting also the privacy preserving mechanism. At the end, the other important aspect, similar to the other project, has been to try to extend basically the EOS interoperability framework with this new component and how they can be part of the global governance and management that is being conceived inside the EOS framework. And finally, obviously, we have, as I already mentioned, two use cases that you will see later what are the topics there. Okay, so in our case, as already mentioned, the vision is that we have, and basically what is the main focus that we already have, is to try to create this kind of end-to-end secure data sharing and confidential platform. Basically trying to work on how in advanced solution for distributed access control, security domain segmentation, and application of protection of data in use, as well as usable and scalable data anonymization technique in that sense. For doing that, basically we focus on three main areas, what we call it, or domains in our case. One of them is the processing part, basically for the confidential data, so that we can allow these capabilities through the different nodes, in this case, that are able to support the confidential computing paradigm. Secondly, through the use of different techniques, as you can see here about data anonymization, that can be used on the access and the data in transit, using, in this case, different techniques like differential privacy, kind of anonymity, and another solution. Specifically, you will see later linked with the identity that we are using as a baseline for the identification of users and services. We also introduced the zero knowledge proof solution in order to give support to several of the attributes and the management of the attributes and the control of the attribute that should be shared when you are doing confidential computing aspect in that sense. And finally, the third domain is that all of this is integrated, as I already said, in a distributed access control using decentralized solution, in this case using blockchain technologies and the management of what you call security zones or cloud security zone, so that we are able to confine basically the area where certain data can be shared, depending on whom you want to share this kind of data and for what in that sense. Okay, so as I said, these all technologies and solutions that we have on our vision, they are already being applied to 2 different use cases. One use case is related to sensitive agri-food governmental data. As you can see here, where we have pilots in Spain, in Aragon, and also in Italy, in Benetton. And the main idea here is to identify how we can facilitate that the information that can be shared or that they want to share between the different entities that are participating on this process can be controlled based on a collection of rules and policies that should be defined by the end user in that sense. And the second case is specifically in the area of health care, but mostly focused on collaborative use of machine learning in this kind of environment. So how the data that can be provided can be also being supported by some AL or AA or ML processing that can be executed on trust execution environment, that in that way, so that we can provide a level of confidentiality on the management of the data that are being treated or provided by the different entities that you can see here. In our case, are 3 main entities, so Charité, the French National Institute of Health, and also the University of Eastern Finland in that sense. Okay, so in order to do that, we already have defined an architecture. Later you will see more detail, but basically here are the 3 main pieces, if you like, that we already are envisioning on our architecture. One of them is how to provide this secure enclave mechanism, so that in some sense we can support the issue that data that are being shared or data that are being processed by the different agents can be have certain guarantees about this execution environment in that sense. So in that way, you will see later, this component should be part of the general processing schema that we are providing as part of TITAN. And by that, you will see later on the technical part that we are using certain technologies, in this case, like Tower, Cocos AI, and other solutions that allow us to create the secure environment that can be used for the different processing aspect of the confidential computing. The other important element that is part of our architecture is that we have adopted the architecture in that sense being defined by the International Space, Gaia X, and FIWARE, in this case, as part of the DBDA, and where we have used the idea of the connector as a piece or as a basic piece of the solution that is in charge of providing the interface for the accessing, processing, and sharing of the data between the different entities that are going to participate in the ecosystem. This data connector, as you can see here, also it's integrated with the identity management solution and the governance of the identity and the key distribution based on the use of the solution based on self-sovereign identity. So at the end, what we are able is to connect, in some sense, the enrollment of the different entities that are part of the ecosystem. In this case, it can be, as you can see here in the architecture, it can be the EA provider, the EA consumer, it can be the data provider or the data consumer of the confidential of the consumer or confidential computing provider. All of them are agents in our architecture that are being supported by this schema of the identity, of self-sovereign identity. And based on this, we integrate the collection of policies that are later being enforced by the data connector when the data or the processing is going to be applied to certain sharing or processing of the data in the architecture. All of them, as you can see here in the architecture, are governed in this case by the policy engine that is part of this authentication authorization infrastructure. That is the one that is going to be connected to the different attributes that are going to be shared and how they are going to be shared by the different entities that are part of the system. Okay, so all of them, later you will see them, how we integrate on our ghetto, but basically these are the 3 pieces that we are bringing in our architecture. What is the actual state of the play of the project? From the architecture, now we have an architecture that is stable with all the components that are defined. We have the sequence of interaction being defined. We have all the actors as already been defined and their functions on this architecture. And we have an integration with the data space architecture as a DSBA reference model. Working with all this schema that I already mentioned. We have components that support the data space connectivity through the use of the connector. We have an orchestrator workflow for the task management and focusing basically on how the different entities should work, and specifically how data that are being provided by someone can be processed by another entity in that sense, so that we can apply certain AI, ML algorithms over it. We have the confidential computer enablers already being instantiated, as you will see, so with different architecture. So we are able to execute in a trustable way all the processing. And again, we also are able to create attestation of that actions. And then we have the blockchain access control and smart contract that are being used on all their process. And finally, we have this privacy preserving ML platform that can be enforced in that sense, or can be applied, or can be instantiated over the trusted execution environment. We have started already with the validation of the use case, as already said. The use case one with the sensitive agri-food data for the regional public authorities, and the second one about the machine learning in healthcare scenario being provided by the other end users in that sense. So basically, we are quite now, I would say, on a ramp-up state, where basically we are now testing and making the deployment and taking some initial evaluation of the result that we are generating. In general, and as a summary, and because this workshop is about secure, confidential and secure data sharing, we understand that TITAN already provide mechanisms that support consumer and producers. As you can see here, different kinds, data processing, confidential processing, algorithms, and services. And we have described the properties and capabilities using this fair approach, so that we can control basically how things can be governed in some sense. We have integrated self-sovereign identity with privacy preserving mechanisms and the use of the DLT, in this case, the blockchain, in order to support a certain access control solution. We provide a mechanism, what we call matchmaking mechanism, based on these meta models. So for describing the capabilities of the different entities, so that we can understand, and that's why it's a workflow, to try to understand who is providing and who are consumers and who are providers, so that at the end we can have this governance architecture. And we support the deployable and configurable connectors with different privacy preserving and confidential models to support the communication in that sense between the different entities. One of the ideas is that in our case, the connector have a kind of basic setup, but basically we can extend it with new capability depending on what is needed, so that if you need a specific privacy preserving tool, there will be a way to deploy this component as an extension of the existing connector in that sense. And basically, we have integrated the mechanism with all this governance to share with whom and how the data between the different entities in that sense. So in some sense, with this confidential computer capability, can, based on the use of this TE, can support really the basically concept that we have about the privacy preserving and anonymization approach that we want to, with whom we want to enrich the EOS framework with this project. Okay, and that's all from my side. I have tried to be brief.
Thank you very much, Antonio. So we have few questions and a few time too, but let me start with the first one. That is TITAN taking resource usage tracking, for example, billing into account as part of the architecture?
In principle, not necessary, but I would say it is not out of scope of what we can do. Basically, the good thing is that's why I say we are having this kind of attestation mechanism, so we can integrate also some other solution, like the one that, for example, for billing, or at least getting track of what already have been happening. That what at the end can become as a solution for a billing and processing.
The next question is, who will be the future service providers of the TITAN architecture?
Okay, this is a good question. Basically, what we are thinking about is that really here for us, I think the most interesting part is the possibility that entities that are providing confidential computing as a provider. So that's why we separate all these kind of agents. So that's why we mentioned consumers and provider in the different, I would say, agents type, because we understand that one interesting point will be that in the future, someone that is able to provide or the AI ML processing, I would say, or the one that is providing the confidential computing processing can be entities that are part of the ecosystem, and they can be, in some sense, offering this service with some cost or not, but that is another story. But that could be something that an added value that you provide over the architecture. And this is going to happen more and more, from my understanding, also because now of all this more important, more need and of processing capabilities that are being required by new applications.
Okay, thank you very much. I think that the next question will be probably taken by Andres, because it concerns trusted execution environments. And then let's move ahead with the second part of the webinar with the technical talks. The first one by Andres Heredia Canales concerning EOSC SIESTA. Andres is a researcher at the Spanish National Research Council. His work is mainly focusing on DevSecOps methodologies and orchestration management tools. He is also a PhD student with a focus on developing confidential computing platforms and has taken part in several European projects such as AI for EOS, Imagine, and the modernization of the Copernicus data store. So, Andres, the floor is yours.
Thank you so much for the nice introduction. I'm going to share my screen. Let me know when you can see it.
We can see it.
All right. So, as I said, again, thank you so much for introducing both the projects and myself. Again, I'm Andres Heredia. I'm going to talk today about the Siesta computing platform in a little bit more technical talk that I titled Navigating the Challenges of Confidential and Scalable Science. And let's start with the agenda, what will we be talking about today. So first of all, a little recap, a quick recap of what we are doing and why we're doing this. And then we're going to talk about TEEs, the trusted execution environments that I consider like the backbones of confidential computing. And then we're going to talk about what else is needed apart from TEEs, because they are not enough. We'll check some use case examples, some basic one, talk about some milestones of the project that we have achieved so far, and then ongoing work, future work, coming soon, whatever you want to call it, and finally, some questions you might have. A little recap, I already introduced nicely the project, but the motivation is the same. I think it's common to the three projects: to create a platform that enables researchers the creation of secure and confidential environments where to perform sensitive data analytics. And here I have put in bold secure and confidential because they are not the same. Something that is secure, it doesn't have to be confidential, because we know how to protect data while it's in storage. So let's say in a hard drive, we can encrypt it. We know how to encrypt our communications. So when the data is going from one place to another, but right now the data in use still being at risk. So if you have permissions, enough permissions, and you can access, especially now in this area of the cloud, you have your data, you upload it to somewhere else, and I could dump your memory. So what you are analyzing in that moment, I could dump it and I could analyze it. So I could retrieve some sensitive information, and we have several types of attacks. So for example, memory replay, cold boot attacks, etc. That it's the motivation that we want to protect the users, the researchers, from this kind of attacks. The confidential computing backbones, TEEs, the trusted execution environments, are, let's say, a secure area of the processor. You can call it like that. There are some extensions that are appearing now to kind of encrypt, well, not kind of, to encrypt the memory RAM, so the RAM that you're using right now, so that no one can access that. And even if they are able to access that, they wouldn't be able to decrypt it. They would be just noise to them. The problem with this is that every manufacturer is a cutting-edge technology, so they're trying to implement it in their own way. They're trying to figure it out the best way to do it. And we have AMD with their secure encrypted virtualization, SAV. We have ARM with TrustZone, IBM, Intel, RISC-V. So, like I created here a little funny picture. So all of them are trying to create, let's say, the standard to lead the way on how to do this. In our case, and because you need the specialized hardware, so you either buy it or you have it already. In the case we have access to AMD SCV processors that are capable to have these extensions. And we're using this to encrypt the memory, as you can see here in this diagram. Every time that you read and you write the memory is being encrypted using an AS128 bits engine that generates the keys to encrypt this using another secure chip, another part of the processor. This is an ARM Cortex-A5 that is inside the AMD processor, and it generates the key using the NIST SP890 recommendations every time that you reboot. So every time that you reboot, you have a new set of keys that are being generated using hardware. One of the limitations or challenges that these have is that as of today, if I'm not mistaken, it doesn't support nested virtualization. This is something that we've been following, and it's been debated if it's a software limitation or until what point is a software limitation, and if in the future we will be able to have it. So this forces us to take some decisions in the architectural side that we will see later. And another of these problems is that, as I said, each vendor is trying to create it in their own way, right? So they created this confidential containers community that is trying to enable and to abstract all this complexity from the users so that you can just use confidential containers without worrying what you have underneath. So maybe you have a place where you have AMD and another place that you have Intel. It wouldn't be a problem because confidential containers it's taking care of that. To do so, they use kata containers. Kata containers are basically micro virtual machines. So this is an important thing to keep in mind because it's also virtualization, right? So it's not a container per se like we are used to, but it's a micro VM. And we're using these both technologies to try to solve this trusted execution environment to abstract it to the user so that it can be replicable anywhere. The problem is that now we have, let's say, an area that is confidential. So we have AMD SCV SMP in our case, so we can have confidential containers that at the end they are VMs, they're micro VMs, so they're kind of similar confidential VMs and confidential containers. But it's needed more than that because TEs are not enough so that we can consider a platform confidential. And I have gathered here some questions that the user might ask or myself, like, for example, how do I know if the platform has not been tampered? So we're going to go to each of these and we're going to see our approach, how we aim to solve it. So for example, how do I know if the platform has not been tampered? So you need to add something like Google Trillion that is now called Desera, that for logs that are like tamper-proofed. Our Coco Trustee, that is an attestation service, also from the Confidential Containers organization, that attests that you are actually running in an environment that has encrypted memory, in this case, AMD SCV, right? How do I know if the code running in the platform is safe? We cannot just run whatever we find online. We cannot just plug something and to start running it. So for that, you need something where to store your code, in this case, GitLab, or where to store your Docker images, like the Harvard registry. So all this needs to be private and controlled. Is my data secure? So we have the part of confidential containers, confidential VMs, that's for in use, but we also need to encrypt, so we need secure storage. We need procedures to ensure that this disk that you're using is encrypted, and maybe you can rely on external services like Vault to store your secrets. Now, how do I control who access or runs what and where? So for this, we have classical solutions. Of course, the first thing that you need to implement is a login, authorization, and authentication infrastructure. In this case, it's Keycloak. It's well-known, it's polished, but this only allows you a level of granularity that you can improve if you implement something like Open Policy Manager, that you can create policies to prevent certain things or certain users to run in specific scenarios, right? Finally, is it scalable? This is one of the biggest problems I think we found, because it's easy right now to create confidential VMs, kind of easy, let's say. Anyway, you still need some requirements, like to have your OpenStack or whatever provider that you're using to be compatible with confidential VMs. It's not as easy as it sounds, because if it's a production place, it's hard to upgrade it, to keep it upgraded. So in this case, to scale it, we choose Kubernetes. That is like the de facto container orchestration management. And inside Kubernetes, we have many components like Coq operator that takes care of the confidential containers, Rook for storage, Wasu for logs, etc., etc. So we have a set of components that, in general, all of it together allows us to scale. And is it replicable? Another one of the problems that we have, right? Like because even if you swear that your platform is really secure, that is confidential, that you can upload your data here, nothing will happen. Still, there will be some places and some use cases where they won't be able to upload their data, or they don't want to upload their data to your site. So what we're trying to offer here is, using DevSecOps methodologies, is to have everything that is replicable, from the creation of the cluster to the dashboard to everything in between. So the Kubernetes cluster, it's a hybrid Kubernetes cluster. It's deployed using Terraform plus Ansible. So that's infrastructure as code to create all the servers, plus configuration management to configure everything and to know that everything is in the state that we want. All the Kubernetes components are also deployed using a GitOps workflow framework, however you want to call it, with FluxCD. So everything is tracked and is deployed automatically. We know what it's in the cluster. We want to integrate everything with GitLab and GitLab pipelines from the start, so the use cases can develop there, and then to build, upload, deploy from GitLab without having to interact with other things, apart from the dashboard itself. So what the workflow to create their environments will be placed in GitLab, and after that, they can run it using the dashboard. And finally, we have some secure hardening and secure storage procedures that are also using Ansible playbooks. So they are easy to replicate, and they are idempotent. Every time that you run them, they will be the same. And so a little use case example. So how is it to use the Siesta platform, or at least how we envision it? I'm going to try to do a demo. Forgive me if there's something wrong, because, demo effect. So I'm going to go to the Siesta portal, right? In this case, we see that I can see the service catalog, but if I try to do something, I'm going to be redirected to the login. I'm going to log in. If you excuse me, I need my phone because security. So once I'm logged in, if I go to service catalog, let's say I want to launch Jana, that is one of our anonymization tools. I can launch it here. I can customize things, persistent, disk, whatever, but I don't want any of that for now. So I want to just launch. I come here, I have some messages, it creates a new namespace, so it's isolated, it attaches some volume, and finally, we will be able to enter. So we are here inside Anjana. This is an environment that is only for testing for now, because of course we're still polishing it, but this is something that is as well protected. If I try to enter from somewhere else, I'm not able to. And this is all integrated nicely and it's transparent to the user. So if I go back to this, you will excuse me, these are like just in case images. So, but what does it imply? So we've seen that it works quick, but to do all that inside the technical part, it involves a series of steps. First of all, the preparation. So as a use case, you will upload your code to GitLab and then execute a GitLab pipeline. So using some templates, this pipeline will build, upload to Harvard Registry, to the private Harvard Registry, where this image will be signed. And they will be scanned by Trivi. So it will be signed by cosign and it will be scanned by Trivi so that we know that this image doesn't have any critical vulnerability and that we have a hash for it. We know which one we're executing. And then this GitLab pipeline will also trigger another procedure to add it to the Siesta repository that is a Helm repository. So all of these services that we're seeing are in the form of Helm charts that will be available at the Siesta dashboard. And then we have, of course, well, this would be like step 0, Google Trilliant, etc. All these services that are behind, they're already running, they're always monitoring things and they're checking. The second step would be, okay, I have my service in the Siesta repository. It's already available in the dashboard. So I logged into the dashboard and I ask for a service to launch. Siesta dashboard, we talk with Kubernetes API and it will request a new deployment, but it cannot just create one and after that verify. It needs to verify first. Is it confidential? So Coco Trustee, the attestation service, will be asked if this environment, if this pod is actually running inside a confidential virtual machine, like a Kata container. And if it is, can I run it? This Open Policy Manager will take care of controlling things like only images from our private Harvard registry can run inside this environment. For example, this is a really simple policy, but we can complicate things and we we can add the level of sensitiveness here with these policies. In the third step, we can finally download the Docker image from our Harvard registry. So using the Nairos snapshotter, because it works differently than the native one, it will allow us to pull from inside the confidential container this Docker image, and we will be able to attach a secure storage so that we don't interfere with the node itself. So every execution is self-contained inside their own namespace and inside they have their own storage. Finally, we have our confidential container running, so we know that is secure and is confidential, so we can safely download, for example, secrets from Vault, and we know that they won't be at risk of someone sniffing our RAM memory or checking our data that is inside. And in the case of Anjana service, it's also integrated with Kicklog AAI because it's a web application. So if we publish it to open it to the internet, that's a problem. And finally, the user will access this service using the Kicklog AAI interface. So we will be redirected first. It will check if it has permissions, and then it will go to the confidential container. Finally, I want to talk about some milestones quickly of how we have achieved so far. So we were able to upgrade our production OpenStack to have support of AMD SCV. This is a problem because it's a production OpenStack, So it meant that it needed to have as little downtime as possible. And we needed to upgrade, I think 2 or 3, I don't remember exactly, versions. So it's a complicated process until we reach the support for the Linux kernel that allow us to use AMD SCV. The dashboard is also launched. You can check it online, even if you can't access. Right now, it's being integrated with Edugain. So every person that has Edugain access will be able to access to a restricted set of services. So you can check how it works. But of course, if you're not part of the project, you won't be able to take advantage of all the features. We have the Kubernetes cluster. It's a hybrid Kubernetes cluster because of this limitation that we can't use nested virtualization. So we have part of this cluster is inside OpenStack, and part of it, the one that runs the secure environments, are bare metal machines. And this is working nicely, it's replicable using Terraform plus Ansible, as I said. And jobs can be run in a confidential container successfully. We have the secure storage procedures created using Ansible playbooks, and we have released these data anonymization tools like Njana and PyCanon that you can check in the Siesta platform and also outside independently. Finally, to what's going on right now, what we're working on. So we have already launched our job. We can do some data analysis there, but we have to still polish and to completely define the secure data output, how we take the data outside, and to have some assurance that nothing is leaking. To finish polishing the pipeline integrations, right now we are working on it. We have some templates and we have initial version, but we really want to have a seamless integration with the user, so it'd be completely transparent. We're also working on security hardening, integrating Cilium network policies, for example, and all these, the sec part of DevSecOps, right? Like to check for vulnerabilities, to automate all these things that I was talking about when you upload your image and it will be signed and checked. We're working on that to really complete it. And we would like to move away from bare metal servers. We've known that there's some efforts going on right now to try to make it, but it's not clear yet how to do it. So we want to explore that because it would be great to have just a normal Kubernetes server inside Kubernetes cluster inside OpenStack. But for now, we still don't. And finally, we'd like to consolidate the technology across all sides. So we have it replicable, but we're also working in parallel. So one side is working in secure storage, another side is working in Kubernetes, another in security hardening. So we want to consolidate all the technologies across all sides. So we have everything in all the 3 sites that will be the providers. We have the same technology. And that would be all from my part. Thank you so much for your attention. I hope I didn't take much time from you. And if you have any questions that you want, I can try to answer.
Thank you very much, Andres. We have one question who says, who is the actor who takes all these trusted execution environment security decisions? Is it the end user, and by default, the user has zero trust to all possible actors?
Yes, exactly. So we built this platform with zero trust architecture in mind. So we don't want to trust anyone. You shouldn't trust, not even us, even if we tell us that it's confidential, that it's secure. So the user is the first one that needs to have zero trust in our platform. And that's why everything that you will run will be inside a trusted execution environment.
Okay, and then other question that I don't know if maybe Alvaro can answer this one, who says that the Siesta architecture document sounds interesting, but it is restricted access on Zenodo. Are there any plans to make this public?
Yes, I mean the architecture is public, should be public in GitHub. The deliverable is not public due to it has not yet been approved by the European Commission. but we will open it just with a warning until it gets the final approved version. Yeah.
Okay, so thank you very much, Andres and Alvaro. And we can now move to our second technical talk by the EOS ENTRUST project. So we have Peter Lengi, who is affiliated with the Institute of Computer Science at the Masaryk University in Czech Republic. He has a master equivalent degree in applied informatics, and he is an IT architect focusing on authentication and authorization domain. He is member of Technologies Work Package in EOS ENTRUST and also involved in other Horizon Europe related projects, EOS related projects and national projects. So Peter, now floor is yours. We can already see your screen.
Hello, and thank you for the introduction. I hope you can hear me well.
Yeah, perfect.
So today I'm here to talk specifically about the AAAI for TRE's blueprint. This is a document which has been published on Zenodo by our work package earlier this year. Version 2 is currently work in progress and will be coming early next year, and version 3 is scheduled to be published at the end of the project. Before we begin, I just want to make sure that everybody understands what the AAAI acronym means. So this stands for Authentication, Authorization, Accounting, or Auditing and Infrastructure. Basically, we are talking about the login workflow, which is the authentication, so that we know who the current user is. We are talking about authorization or access control, so that we know what this user can or cannot do. And we are talking about tracking and analyzing the events which the user has done. And the infrastructure here is the technology, the processes, and also the personnel that enable all of these three capabilities. The primary objective of the TRE's AAAI for TRE's blueprint is to enable federated TRE use via standards and technology. The blueprint begins with a list of requirements, and since there was no canonical glossary of AAAI terminology at the time, we created one specifically for this project. We have based the blueprint on an existing blueprint architecture published in 2019 by initiative called Authentication and Authorization for Research and Collaboration, which is a European project that has designed building blocks for international research collaboration, and a number of authentication and authorization infrastructures have been implemented based on this blueprint architecture and have been operating in production for a number of years, so that we know it's a solid foundations. Even the current EOSC Federation is now making adjusted an upgrade of this blueprint architecture for the EOSC Federation, for the AIs that will be fueling the EOSC Federation. The main content in the blueprint are the extra capabilities on top of the basic blueprint architecture that are required by TREs and their federation, mainly the federation. This is the need to know the true identity of the user so that we can possibly later audit it. We solve this with a strong identity vetting process. Then we also need to know that the person who was vetted originally is still the same one who's using the systems. So we solve this with multi-factor authentication. We need to permit what these users can do in the federation, not just based on who they are, from where they are, and what they are accessing, but also on the attributes of the environment itself. So we have decided to move towards attributes-based access control, which was also mentioned by the other two projects, per the designs made by NIST. We have debated possible use of GA4GH passports from the genomics world, but we haven't found strong use cases to move forward with this so far. And a major thing that was missing from the original ARC blueprint architecture and which we introduced and are implementing is accounting and auditing of the user access. So we know that our project partners are also working on accounting and auditing of other events, but for the purposes of ENTRUST project, we are focusing only on access. As for the upcoming second version, that is currently in an early draft, we are reflecting new requirements and developments that have occurred in the past year since the first version was published. New requirements coming from trusted research environments themselves are integrating with a federation level AAAI rather than replacing what they already have. The original blueprint that we prepared was assuming a more greenfield environment, but we found out that that was not true. Another requirement is that for many cases, group-based or role-based access control is pretty sufficient, and we do not need to be making the systems more complex for the end users. We will be working with TREs on finding the best solution. We know that both attribute-based access control and group-based access control need to be supported, but we still need to identify the exact ratio. And for attribute-based access control, we need to get more clarity on what the policies actually need to look like. Then this year was also or as Ulrika has mentioned, new ENTRUST blueprint and interoperability framework. So the general architecture of the TRE Federation has been published. And since we are two different work packages, we once again need to realign. So that will be also our focus for the next month. There were also new developments in the AAAI world. So as I've already mentioned, mainly thanks to push from EOSC Federation, a new version of the ARC blueprint architecture is being prepared. So we will be also realigning with that, though the improvements there are quite minor, in my opinion. Also, the ARC initiative has produced what they call a compendium. So this is mainly aimed at service providers and policy makers in institutions and in federations on how to choose or how to build a AAAI solution for their use cases. And there was a number of recommendations, mandatory guidelines, recommended guidelines. So once this is published, we will also make sure that our blueprint is aligned with this. And there's also currently hope that this compendium will finally come with a canonical glossary of terms. So we would also very much like to adopt that if it exists. There's also, in the technology world, there's the OIDC Federation is currently being developed. So far we've struggled with the fact that only the SAML protocol was supporting, well, in a nice and solid way, federations between AAIs. Now OIDC protocol should be able to do the same. There's standards currently being finalized that will move us towards that. And EOSC AAI Federation is coming up with a new architecture early next year as well. So we will try to pre-align with that. We are struggling with the fact that there is still no truly universal identity vetting solutions. So if there's any tips that you could share with us, we would be happy to hear them. But we will continue to look for workarounds that we need to enable TRE Federation. And all of these developments are still ongoing, so we will continue reflecting the new developments as they come. That's it for my short presentation. Judith, is there any questions?
Thank you very much for your presentation. And we have one question that maybe you can address because it arises during Ulrika talks, but is related to trusted research environment. So what are the criteria for commercial and trusted research environment providers to be listed in the Tier E inventory?
That might actually be better suited for Ulrika if she can open her mic and ask first. She's part of the provider forum.
Otherwise, maybe we can share later on well, Ulrika told me to share her contact just to address these other questions that arise. So I will share with the registered participants just in case that they want to clarify something.
Thank you. But technically, this means as long as they are aligned with the ENTRUST architecture and the AAAI for TRE's blueprint architecture, it will mostly be a question of policies and procedures on how they should get involved. Like technologically, I think we can describe it. Policies are still developing within the project. So hopefully we will get a better answer next year.
Okay, so then thank you very much for your presentation. And we can move to our last but not least presentation from the EOS TITAN project. So Antonio, thank you very much for giving also this technical talk.
Yeah.
And the floor is yours.
Thanks. Okay, so maybe I will go directly to the main aspect that we are developing as part of the TITAN. I think the good thing is that already in the presentation of Siesta, some of the issues and why we are using confidential computing and the environment that we are using also has been clearly explained. And I think it's quite nice and the synergy that we can have there in that sense. So just to mention that, as I said, coming back again to the general architecture, take into account that in our case, we have an approach that try to link a little bit what already has been defined in the context of the EOS architecture, but also taking into account what already is happening in other data space architecture definition, if you like to call it in that way. And that's why we are aligned in our case with the Gaia X, and the data space service center, where basically the one key component for the provision of all the process for the data sharing is being done through this idea of the connector. So as you can see here, in our architecture is another view of our architecture where we are separating, I would say in some sense, are this what we call consumer and producer. Remember that from our previous presentation, we have different types of consumers or providers, depending on what they are. And basically one key piece that is supporting all the process of the data sharing in that sense is the integration of, in this case, inside the connector, the idea of the credential manager, the PDP and PEP that is in charge of defining the policy and enforcement the policy that are going to apply for the privacy or for the data treatment, and then link it to that one, a collection of privacy preserving tools that are facilitating the possibility of doing data anonymization or applying different kind of treatment of the data previous to the sharing with the rest of the with entities that are asking or want to consume that data in that sense. So at the end, as you can see here, in order to manage this procedure, we in our architecture, a part of it, we have our governance model that is basically based on this authentication of authorization infrastructure, similar to what already has been mentioned by my colleague from ENTRUST. The only thing here is that we are using a technology based on SSI, and basically using that one, we are leveraging all the policies and the attributes that are being associated to the different agents and how they want to define different restriction about how to share data or share part of the data depending on with whom or who is asking the data and for what in that sense. So all this is part of the policy management that is linked to the PDP and PEP component that is in charge of managing that. No, and this is a little bit what we say here. At the end, we have this sovereign part that is being managed by the infrastructure, and then we have the connector as the piece for the supporting the data interoperability between the different components that are entities that want to share the data in that sense. Okay, so similar to what already Siesta is also doing, one important piece is, okay, one thing is that you want to share, but basically when you want to share or when you want to do some treatment, you need to define certain kind of workflows so that we can create and define basically what will be the treatment that is going to happen, who is providing the data, who is maybe providing the algorithms, and who is going to provide the processing entity where all these data and algorithms are going to be executed in that sense. And for that, similar to what already was also mentioned, we are integrating a workflow where we have the use of GitHub, TerraFlows, Ansible tools in that sense. So at the end, we can create the connection with the idea that at the end is that all these components that are part of the workflow at the end are integrating this connector as a piece of the component in order to be able to complement basically the workflow with the management that is being provided by the connector in order to define and to control how the data are sharing and what processing is needed to be done on the data in that sense. So one important piece of this workflow, as you can see here, is that the possibility that one of the entities that is part of the workflow is going to provide a confidential computer environment where it's going to be the data being to be provided, or where the data is going to be executed over this environment in that sense. And at the end, we are extended the functionality of this component with the connector, as I said, in order to support all the workflow that we are defining as part of our architecture in that sense. As I said, important piece of this architecture is that inside the component we have this the PDP and PEP that is connected to the as already mentioned, to the identity to the authentication authorization infrastructure. And we are using the concept of the wallet, so that basically the wallet is an entity, is part of the component that is part of is part of the component that is integrated on the connector, so that we are able to integrate all the entities that are participating in the workflow in a similar way, and connected to the services and managing that is being provided by the authentication authorization infrastructure in that sense. So here you can see in one side the picture is the typical one that is being defined on the architecture of the data space, where basically we have the different connector, we have the identity provider, and then the important thing is that once the entity, every connector is identified and is and receive a request from another connector, there is a process of negotiation based on the DSP protocol, and as a consequence of that, after the negotiation, a data sharing is being produced, taking into account the rules that should be applied by the PDP and the PEP that are part of that connector, linked to the data that wanted to be shared and to the information about who is asking about that data concretely and for what purpose is being requested the use of that data in that sense. So all the processes connected all together, so that at the end we are able to manage and provide the governance based on policy and the control of the access control of the workflow that we are generating. Here you can see a little bit an example in detail about the connection and the interaction between all these different pieces. We have the catalog, where we have the publication being provided by the providers in that sense. We have the definition of the contract that are associated to the different data sets, and then basically on the corresponding consumer that is making a certain request about that certain data. There's a negotiation process, a contract agreement, basically between the two parts, depending on the specific requests that are being provided in that sense. And as I said, here you can see the details about the interactions that are happening in all this process, and taking into account all the different components that I just mentioned in that sense. So I think that this is an important piece, because at the end here you are defining the rules, basically, in that sense, about how the things are going to be shared, and how the confidential computing and the data sharing process is going to happen, depending on the specific policies that are being defined by each of the different agents that are part of the global ecosystem that we are having here in that sense. For the data processing part specifically, as already mentioned, we have defined a type of provider in that sense. In this case, here you have two types of providers that we are already implementing in our architecture. One of them is based on the TE, as already mentioned. This is quite related to the example already being provided by SIESTA, where basically we integrate a confidential virtual machine that can be executed over different kind of I would say infrastructure. Here you can see in our testbed that we have a standalone node or standalone with the GPU or a standalone or a cluster with a certain virtual machines, etc. So the idea is that the entity, the confidential computer provider is also describe the capability that they have, so that when another entity want to request a certain service, they can understand which kind of capabilities are available on this confidential computer environment that is going to be executed. The other one is based on the federated learning in that sense. So another test evaluation that we are carrying out is the possibility that the procedure basically for the treatment of the data, specifically when we're talking about AI ML algorithms, is being done locally in some case using federated learning approach. So at the end, the data are not being published, but basically the models that are being generated is the only thing that they can be shared between the different nodes. For example, this is something that we are applying actually, for example, in the scenario of the agriculture to check basically and to facilitate basically that the different participant in that sense can get more confidence about how their data are not being exchanged in some sense directly between the different farmers, for example. So in the case of the confidential computer, as I already said, here we have integrated two different tools. One of them is Tower, that facilitate to create a workflow, as already mentioned, using the TerraFlow mechanism. So we create a lifecycle, basically, manager that orchestrate the workflow execution, taking into account that one of the nodes that can execute basically the workflow is going to be a TE in that sense. As you were saying here, and this TE scenario, this configured computer, is being implemented in our case also on the scenario of another component or tool, like this case, that is Cocos AI, that basically facilitate also the use of different kind of infrastructure, as you will see later in that sense. In the case of this interaction, the good thing is that we have a collection of components that are interacting, as I already mentioned, not only because we are able to do the execution, but also we are able to monitor that execution. This is linked to the question already being provided about possibility of doing some kind of accounting and so on, because here we are also able to generate certain attestation solution about how and what is being executed on this kind of environment, on this TEs that we are showing here in that sense. So we have different agents, and part of the workflow that we create is the connection between, the agent that is providing the interface for the request and the entity that is going to do the real execution on this confidential computer environment in that sense. We support different kind of scenarios, already said, Docker, Python, Wasp, etc. And the idea is that you will see the manager is at the end supporting basically the confidential virtual machine that in this case is executed on, as I said, on different platforms, possible platform or infrastructure, in order to provide basically this capability. So that's why it's important that one of the important aspects is that we are able to describe the capability of what is possible to be offered, so that when you decide what workflow to be executed, you take into account this capability depending on your requests and your needs, etc., on the kind of processing you are going to do on your with your data, for example, in that sense. For the federated learning, as I already said, similar here, we are integrating and we are orchestrating a collection of different components based on the Flower solution. So you can have here, as you can see, the deployment of the different clients over the different nodes and how they are being later aggregate and coordinate through the use of the Flower server in that sense. This facilitate, in our case, one aspect that we are envisioning here is what we call the secure zones, so that basically we can restrict in some way what data to be shared outside the certain zone, because in that sense it's not sharing data, but you are sharing only models. And either with the models we are applying different approaches like homomorphic encryptation or other solutions. So at the end, we can restrict much more either the way the data are being shared or in that kind of environment in that sense. Finally, just to show you this example is, for example, the one that I already mentioned that we are applying now also to the not only to the agro but also to the healthcare regarding to the sleep stage classification, so that the different entities that are participating in a collaborative training coming from information that run on their own hospital, so that they are not able to, they don't necessarily are able to share the data and only manage the models that they are sharing later for their research activity and so on. Just to conclude, so in that sense, so how what TITAN is providing in this kind of environment here, as I already said, is more or less a summary of also what I already given in the general presentation. We have a complete TITAN security stack in that sense that facilitate basically the solution. We are having we provide a mechanism to allow different kind of consumer and producer, as already said, and basically we are deploying this architecture based on DSBA that in some sense allow us also to facilitate interoperability with other data space in the future and so on. And finally, something that I don't mention here, but also we are now working with the people with the group of EOS about AII, is to work on the interoperability between the SSI and the ARC AII infrastructure, so at the end we can connect basically the two subsystems in a quite I would say seamless way. That's all from my side.
Thank you very much, Antonio. I think that you have a previous question, but I think that it concerns your first presentation, because the question talks about the architecture in which you mentioned data anonymization. So the question says, in the architecture you mentioned data anonymization. It is done locally by each user or in a dedicated site? And which tools are used for that purpose?
Okay, sorry. Yes, I mentioned it is configurable in the sense. So the main idea is that depend on the policy that you define also on the connector. So basically, one approach, the most natural one, is that in your policy, you can define that the data previous to be shared, they should be anonymized, pseudo-anonymized, or should be treated in some way by certain privacy preserving tools, as already put in here, for example. So the main idea is that this is part of your own policy. The other option is that you can decide that your data, and because you have confidence about another provider, for example, a confidential computer provider, you are able to share the data, but the execution of the algorithms, because of your capability or whatever, is being done basically on the confidential computing node. In that sense, so the summary is that we have flexibility about where and who apply the rules of doing the privacy preserving or the anonymization technique.
Okay, so thank you very much, and then I think that we can conclude. So first, I would like to thank you all the speakers for joining us in this webinar, but also to all of you that have joining us today. And we invite you to stay tuned to the channels of the three projects, to the social media channels, but also to their newsletters that are published in regular basis. And as we hope to continue this collaboration between these three projects that are all funded under the same Horizon Europe call, we invite you to stay tuned to future events and to future programs that we are going to probably organize together. So thank you all very much and have a very nice day.
Thanks. Thanks to you.
Thanks. Bye-bye.
Thank you. Bye.